Now let's talk about the acute ASS situation. So again, let's pretend we have capital A, lowercase b. It's ASS because this letter matches this letter. If it is acute, in other words, this is less than 90 degrees, the first thing you're going to have to do is find the altitude or the height of your triangle. Okay, so again, let's take a look at all three of our setups. So this is angle A, and if that's angle A, then this must be side B. It cannot be side A because side A has to be across from, not touching angle A. First thing you're going to do is you're going to find the altitude, the height. And it's going to be a pretty easy situation. All you have to do is take those two numbers that you first jotted down, this side and this angle, and it's always going to be B sine of that angle A. Okay, same thing here, same thing here. Okay. Now what you're going to do is you're going to compare your side A versus the height. Okay, so your side A could either be less than the height, could be equal to the height, or it could be greater than the height, the altitude. If your side A is shorter than the height, in other words, from top to bottom is the altitude, your side A is smaller than that, then it's going to be no solution. Why? Because there's going to be a gap in your triangle, which means you don't have a triangle. A is too short. If A happens to equal the height, so from top to bottom, A fits that perfectly, that's kind of exactly what we wanted. You're going to have one solution. And more importantly, that's going to be a right triangle, which makes it pretty easy to solve for because we can reapply the Pythagorean theorem. And then the last case, supposedly the trickiest one, is what happens if A is larger than the height? Well, if here's the height, the altitude, and if A is larger, I can't just stick it straight down and poke it through the ground. What I have to do is I have to lean a little bit to the right, or I could possibly lean a little bit to the left. So A is either going to land here, so this is going to be angle B. I'll call this B right, and this, or it could be leaning this way, B left. So in this case, we have two possible solutions. And that's where things get a little bit tricky. So I'll re-diagram this so you can kind of see those two. So the first one is going to look like this. Okay, so it's going to be A, B, right, and C. And then the second one is going to be if I lean to the left. So it looks a little bit more like this. The key to this is the relationship between this angle and this angle. So if you notice, if we go back to the original setup, both of these are side A. I mean, it can't change, which means it's an isosceles triangle. So what is the relationship between this angle and this angle here? This one is always going to be 180 degrees minus this first angle. Always. Why? Because if these two are the same, then these two have to be the same. It's an isosceles triangle. And this is the supplement of this one right here. So if once you set this up, applying the law of sine to both of those, then you'll have your two answers.